Now let's look at similarity. So similarity is a very simple topic. For similarity, there are things that we need to consider firstly. Saka chincha unofana kutanga kuziza firstly is that similar shapes anima corresponding angles which are equal, and the second thing is that it has corresponding sides that are also equal. So you can see that shapes are similar mainly because they have these two things, which are corresponding angles which are equal, as well as what corresponding sides which are equal. So let's look at our first example, which may give us a picture similar. So look at this. It says name the triangle which is similar to ABC. So here we want to see that's ABC. So ABC will be similar to, so this will be my sign for similar, which are three lines that are vertical. Then ABC will be similar to, we say that they have corresponding angles that are equal. So we are going to look at the angles. So my angle at A is this one. It is similar to this one, which is X. So here I find X. Then we have my B is here. It is similar to Z over the side, so it will be Z. And then lastly, my C, which is this one, will be similar to this one, which is Y. So here ndatuona kuti ndawana a triangle which is similar to ABC. So that's the first thing that you do when you consider similar triangles or similar shapes. Let's get to an example, another example. So it says name the triangle that is similar to AXC. So AXC. So, but when we look at this type of an example, we find that there's something chinyo and chapo. We have my parallel lines. So we have my BD and my AC. These are two parallel lines here. They're parallel. So if they are parallel now, it means that I will find my Z angles being there, or even F angles. So this angle here will be equal to this angle, and then this angle here will be equal to this angle. So that's the first thing to say or identify. Then after that, now takuchenda to our game, we say AXC is similar to, then we look at the A yedu yakafanana nachi na B, so that would be B. Then our X yedu, secondly our X is just equal to the X. Then our C yedu yakafanana D, so we have this. So the triangle that is similar to AXC is BXD. Then we go to the third example. So for the third example here, we are asked to find the triangle that is similar to ABD here. So we write our ABD. ABD is similar to. So one thing that you have to notice is the first thing wafana kutanga wana kuti ABD yako, which triangle is it, especially on these cases. So you identify it, it's A, then B, then D. So we would have to consider the angles that we'll be having. So panapa, I'll just say this one I'll place 2, then this one I'll place 3. Then after this, I would also come, so this one was the ABD was the larger triangle. Then I'll go for the minor triangle, which is B, D, and C. So for this one, I'll try to find the angles that might be comparable. So this one here, A, it compares with this one. And then this one, which is the largest here, D, we have this one also being the largest, and this one having this too. So now we want to find the triangle which is similar to ABD. So the one which is similar to A is okay. I can say that we can say that we have nullified this triangle. and then we are only looking at this triangle here, this one. So the one that is similar to A here will be this one. So the letter it's what? It's B. And then for B for the triangle ratanalify, the bigger one, it was in a 2, then to end up in a 2, which is what? C. And then the D and get in a 3 to end up in a 3, which is what? D. So in other words, ABC is similar to BCD. Then after this, we now have to know the most important thing, which is calculating unknown lengths of similar shapes. So for similar shapes, for us to calculate that, the first thing that we have to do is to find what we call the scale factor, or sometimes you just say SF to mean scale factor. So the scale factor is the one that is important to calculate, because it's more like ndoya tinoshandisa for doing my ratios such that we can come out with calculations that can give us values. So for example, you're given if you're given an expression like this one, which means that A, B, C is similar to X, Y, Z. So if you're given this, you can now interpret this as A, B all over. So the first 2 will be over the second 2, which is X, Y, will be equal to the second 2, which is BC, all over the second 2 here, which is YZ, is also equal to the first and last here, which is AC, and also the first and last here, which is XZ. So this one, AB over XY, will be equal to BC over YZ, will be also equal to AC over XZ. So kana tatora these ones, we can then find that for these ones, this 1, 2, and 3, if we are supposedly we are given values and then we substitute values, we'll find that maybe 1 inokwanisa kuvaita ama-values ese, then that becomes our scale factor. Let's say, for example, we find that AB over XY will be equal to 2 over 3. So it would mean that 2 over 3 here will be what I call my scale factor. Ndo yandienda kuchishansa for calculating values are unknown. So let's see that in this example, which is example number 1. So the first thing here, we're given, we are asked to find the length of what? X and Y. But for us to find the length of X and Y, the first thing chatakuta ndechekuti isusu takushitanga tatarisa the angles, the triangles that are similar. And the triangles that are similar here, it's what? ABE is similar to ACD. So here we get what? AB all over AC will be equal to the second 2, that's BE all over CD, which will be equal to then the first and the last here, that's AE all over AD here. So after having done this, the next thing that we have to do now is we have to find the scale factor. So now I'm going to be substituting my values anenge ari pa this diagram randinaro ndichima substitute on the things that I found here. So my AB, A to B, that's what? 3 all over A to C, A to C yangu, that's what? That's 3 plus Y will be equal to, then BE, my BE is equal to 4 all over my CD, my C to D here is 6, which is equal to, then my AE is X centimeters, it's X all over my A to D is X plus 2. So as you can see, panapa now we have obtained this value. So this value becomes our scale factor, and then we reduce it, and after reducing it, it becomes 2 over 3. So 2 over 3 is the scale factor that I'll be using for me to calculate the value of y and also the value of x. So for me to calculate the value of x, I would then take this expression for x here, and then I would say x over x plus 2 will now be equal to my scale factor, which is 2 over 3. Then I simplify that using cross multiplication. That becomes 2x plus 4 will be equal to 6x. Then here I take my 2x to 6x, it becomes 6x minus 2x will be equal to 4. So here I find 4x will be equal to 4. Then I divide both sides by 4 to get x being equal to 1. So here I have my x value being equal to 1. And then for my y calculation, I take this expression with y here. Then I would say 3 all over 3 plus y will be equal to my scale factor, which is 2 over 3. Then I cross multiply, then I get 9 will be equal to 3. That will be 6. 6 plus 3y. Then I take my 6 to the other side. It becomes 9 minus 6 will be equal to 3y. Then I get 3 is equal to 3y. Then after getting this, then I divide on both sides by 3 by 3. Then I get my value for y. Then my value for y here will be equal to 1. Now for us to see how this really works, we look at this example number 1. So for example number 1, we are asked to find the length of x and also the length of y. So the first thing that we are going to see here is that the triangle ABE is similar to ACD. So usati any calculation for these zvaunofana kutanga wanyasoona is the triangles that are similar to each other, because those triangles are the ones that are going to give you the scale factor with which you then use. So let's look at our example. Then here would use the previous concept. Say that A of AB all over the first ones, that's A, C, will be equal to then B, E all over CD, which is now equal to these ones, which is A, E all over A, C. Then after having this, the thing chatakutofana kuita ndechekuti takuchifana kusubstitute my values ari pane this whole thing from this diagram that we've been given by the question. So let's look. AB edu according to our diagram, AB edu is equal to 3. So we have our 3 all over AC edu, A then to C, that will be 3 plus y. So that will be 3 plus y, which is equal to, then our BE we find out it's 4 all over, then our CD from here to here, that's 6, which is also equal to, then our AE, A to E, that's X all over, then our A to C, which is here to here, A to D, sorry for this, it's D here, then A to D, that would be X plus 2, so that's X plus 2 here. Then after having done this, chinhu chatakufana kuona ndechekuti pabuda these values are what we call our scale factor. So then our scale factor yedu tichabva taireducer, and then it becomes 2 all over 3. So 2 over 3 that will be what we use as our scale factor. Saka you want to reducer, kana tunokwanisa kuregedza reducer, still the same works. So let's go to the calculation for x. So now for x, we are going to use this expression to calculate. Then we'll be saying that x all over x plus 2. Now we'll be equating it to the scale factor, which is 2 all over 3. Then now taku simplify by cross multiplication. So 3 by x, that's what 3x will be equal to. Then this one, negative 2 by x plus 2. So here we find 2x plus 4. This one is 3x. Then our 2x goes to the other side. Then it becomes 3x minus 2x, which will be equal to 4. Then here we get x being equivalent to 4. So our answer for x is equal to 4. Then for our calculation for y, we're going to take this expression, let's do it on the side. So it will be 3 all over 3 plus y, which is equal to, then we equate it to our scale factor, that's 2 over 3. Then after this we do cross multiplication, then 3 by 3, that gives us 9 is equal to 2 by 3 plus y. Then here we get 9 is equal to this by this, that's 6, plus this by this, that's 2y. And then 6 goes the other side, then it becomes 9 minus 6 is equals to 2y. Then here we get 9 minus 6, the value that we get there is 3, which will be equal to 2y. Then we divide on both sides now by 2, then we get 3 over 2 being equal to our value for y. Forgive me my board. Let's also look at the second example. So for our second example now, we are asked to calculate the sides yz and wz. So here, if you want to find we want to find the triangles that are similar, it's a yzw will be similar to wxz. So here we would now say yz all over wx will be equal to zw all over xz, which will be equal to the last ones, which are those ones. Then that would be y w all over wz. So after this, we're just replacing like what we did in the previous example. So my yz here, my yz remains yz all over, then my wx is 5 be equal to, then my zw remains zw all over, then xz, then you have x here to z. So this will be 3 plus yz, that will be 3 plus yz will be equal to, then we have our yw, that's 4 all over my wz remains wz. So now you see that the first one is complete, then the second one is not complete, then the third one is not complete. So what we do now is that we look at all of them. Is that okay? So then after looking at all of them, the top number, this one you'll be doing it for you to find the scale factor. So the scale factor will be equal to the top number, that's 4, and the bottom number here is 5. So the scale factor that we are going to be using is 4/5. So now we are going to calculate for YZ. So what gives me YZ is this first one. So this first one here, I'll be calculating it here. YZ will be equal, YZ/5 will be equal to the scale factor, that's 4/5 here. Then I multiply 5 on both sides. Then I find that YZ will be equal to 4. Simple. Then the second one, we want to find WZ. So for WZ, we're going to be using this one. So we say 4/WZ will be equal to 4/5 here. And then here multiply WZ on both sides. That gives us 4WZ will be equal to 20. Then we divide on both sides by 4, and then that will give us WZ being equal to 5. So this is what we do for this one. Then the next thing that's quite different from what we're doing is now we want to find the areas of similar shapes. So this is quite simple. We have learned how to find the scale factor, so it should be quite simple for you to find these ones. So to calculate the areas of similar shape, we need to firstly find the area factor. So this area factor is the one which we'll be using for proportionation. And for you to find the area factor is equal to the scale factor squared. Let's say, for example, you have been given this, which is ABC is equals to is similar to this. You did your thing AB over over XY is equals to BC all over YZ thing, so on. You did this thing, and then after doing that thing, you then got a scale factor. You got a scale factor, right? Then after getting that scale factor, let's say, for example, supposedly the scale factor you got it as 2/3, supposedly. So for you, after getting the scale factor as 2/3, this scale factor now, because this is a fraction, but then this fraction is also a scale, so this fraction can be represented as a scale as 2/3. So now this was the scale factor. So for me to find the area factor now, it will be equal to, then I would say 2/3 then squared. Then here I would find it being equal to 4/9. Is that okay? So this is how you find your area factor. Then let's look at one example. So the first example here, we are asked to find the area of A, which is this one. So here, the relationship between the two triangles, the equity pana 3 on the side and pana 6. So these are corresponding sides. So if they are corresponding sides, they can give us the scale factor. So the scale factor here, it was 3/6. But then the area factor will be equal to 3/6 here squared. But mind you, this one you can, this scale factor, you can simplify it to be 1/2. So here I'll just use the simpler one, 1/2 and square it. Then I find the area factor being equal to 1/4 here. So after finding the area factor is 1/4, I then find the area of A. So area of A. For my calculation now, I'll say 1 is S to 4. So 4 is for the bigger triangle and 1 is for the smaller triangle. So the smaller triangle it is an area of 4. So then I'll say 4 is to more. And then I get 4 over 1 multiplied by 4. Then I get my area as 16 square centimeters. So having done the first example, now let's look at the second example for this type of questions. So now we are asked to find the area given that the area of a xy is equal to 8 square centimeters. We are asked to find the area of ABC. So here what we need to identify is the area, which is 8 centimeters. That's AXY. So that will be AX right here. So it's for the smaller triangle, that's 8 square centimeters. So having done that, the next thing is we want to see the corresponding sides. So we'll go where we have our values here so that we can see the sides that are corresponding. So for my values that are given, I've been given AX. So my AX is here, it will correspond with AB. So the way it corresponds is that it's AB over AX. So this one will be equal to, then my AB is 3 all over the AX, that's 2. So in other words, this will be the scale factor that we'll be using. So my scale factor will be 3:2. Then my area factor will now be equal to 3:2 squared. Then here I find 9:4. So after having find 9:4, now I want to find the triangle of the bigger shape, which is ABC. So here I'll say 9 is S2 4. Then what I was given is 8, which represents the smaller triangle. So I'll put it on the smaller side, which is here. And I'll say 8 is S2 more. Now after this, now it's now equal to 8 all over 4 multiplied by 9. And then I find 2 multiplied by 9, then I have 18. So it will be 18 square centimeters. That will be the area for ABC. Let's also look at example 3. For example 3, we are given that AD is equal to 3 centimeters. So look at this now. It's quite different from the previous one that we're doing. Now this one, you are not it is not labeled, so there is need for us to label. So each and everything that you're given in a question is very important, such that you use those things to find or to direct yourself to the answer, or to direct yourself to the way of calculating the required things. So here ndakuti inini AD yangu will be equal to 3 centimeters. Then I go here, that's my A to D. It is equal to 3 centimeters here. And then AB is equal to 5 centimeters. So AB is equal to 5 centimeters. So 5 centimeters here. It's 4 here, extending to this part. And then the area of ADE is equal to 6 centimeters, 6 square centimeters. So ADE, so my A, D, then E. So it's the smaller triangle, which is equal to 6 square centimeters. So after having done that, I now go to the triangles that are similar. So the triangles that are similar, it's ADE is similar to ABC. So those ones are going to give me my scale factor, which I'll be using to find the area factor. So here I would then look at the sides that are given. Then I'm given AD. So AD is 3, so I'll choose where there's AD. AD is corresponding with AB, so I'll say that AD all over AB will be equal to, then my AD is equal to 3, then my AB from here to here, that's equal to 5. So in other words, my scale factor is equal to what? 3:5. So if I have my scale factor here, I then can calculate my area factor. So my area factor will be equal to 3:5 all of it squared. Then I find 9:25. So this one is the one that I'll be using to calculate the area that is required. So firstly the area that is required is ABC. So for me to find ABC is this one. It's this whole triangle, which is the big one. So I'll then say 9 is S2 25, and then given 6 square centimeters for the smaller one, so I'll put it at the smaller side. So 6 is S2 less. So here I'll then now say 6 over 9 multiplied by 25 here. Then I would get, if I say 3 into that, that would be 2. Then 3 into that, that would be 3. Then that gives me, 2 times that would be 50 all over 3, which is equal to, let me look at my figures, let me calculate my figures. Then I would find that the area would be 16.7. So 16.7, that would be the one that I find if I divide that. Then this one would be a figure which I would have rounded off. Then after that, I'm also asked to calculate the area of DECB. So notice something, DECB, that would be DECB. Note that it is not a triangle, but it is a trapezium here. So this one is the area that I want to calculate. So for me to find that area, it will be equal to, so it will be equal to the smaller, the bigger triangle, subtract the what? The smaller triangle, which is equal to, so I'll subtract this bigger triangle here, will be subtracted by the smaller one here. Then I'll get the area which is remaining of the trapezium here. So my area will be like this. It will be 16.7, subtract 6, that will give me 10.7 square centimeters. So this will be my answer. Then finally, let's look at the volumes of similar shapes. So for finding volumes of similar shapes, also the same thing is required. The scale factor, and then now when we look for our scale factor, the next thing that we'll do is to find the volume factor. So this volume factor is found by saying that volume factor will be equal to the scale factor, but this scale factor is to the power of 3. So when we did the area, it was to the power of 2. Now it is to the power of 3 to represent volume. So let's look at the first example that we have here. Then in our example, we are asked to find the volume of the smaller shape, which means the volume of this shape. The volume of the bigger shape we have been given, that's 60 cubic centimeters. So now, after having done this, we have to know the scale factor. So the scale factor here, we're going to look at it using the corresponding sides. So 10 corresponds with 5. So in other words, my scale factor will be equal to 10 to 5. In other words, that will be 2s to 1. This would be my scale factor, which means that my volume factor would be equal to 2s to 1 to the power of 3, which would be equal to 8s to 1. So this would be the volume factor that I would use. So my volume factor now, I would then say 8 is s to 1, and then here the volume that was given for the bigger triangle, the bigger shape, sorry for that, the bigger shape is 60, so I would put it here on the side. 60 is s2 less. Here then I would then say 60 over 8 multiplied by 1. So if I simplify that figure, then I would find the volume of the smaller shape, and the volume of the smaller shape will be equal to 7.5 cubic centimeters.